Welcome back. So in the first video of graphs of trigonometry, I discussed about the basic graphs of excuse me, y equals sin x, y equals cos x, and y equals tan x, and then I drew the graphs of those, and I explained to you what happens actually to draw a graph. And then in the second video of this course, which is on the complex problems on graphs on trigonometry, I explained to you as to how a general graph, the equation of the function of the definition y equals a times sine bx plus phi, or a cos or a tan graph, can be drawn. So if you have not watched that video and the video before, I invite you to watch those before coming here, because I'm doing actually a series of lectures on this, so it will be actually a flow from the beginning to the end. So if you have not watched some previous video, and on the following lectures also it will be the same effect. If you have not watched a following video, you will not understand as to what I am speaking of. So I invite you to first visit that video and then come back here. And in this video actually I'll be focusing on drawing complex graphs. So I will first draw the y equals sin x graph again. So this will be the y equals sin x graph, but I'll draw it again because it's useful actually for both for me and for you to understand the first concept in drawing the complex graphs of trigonometric functions, which is called flipping over. So actually flipping over and some other words. So I will, in this video I will be talking about flipping over, amplitude transformations or translations, and phase transformations or translations. So those will be new terms. Those are not the actual terms that have been obeyed by the scientific community. So those will be the terms used by me. So those are not real terms. You can observe those. So those are not the actual terms. So those terms will be used by me to explain this video. So I'll draw y equals sin x, then introduce you what is meant by flipping over, and then I will go to different transformations. Okay, y equals sin x. So this is the graph. I'll draw it again. So this is the x-axis. This is y. So this is equal sin x. And I will draw it again in the same interval between 0 and 2 pi. So this is 5 by 2. This is 0. This is 5. This is 3 pi by 2, and this 2 pi. Alright, so this is a graph. So the amplitude is 1, and the maximum displacement so is 1, and in the other direction it's minus 1. Alright. So this will simply be the graph of y equals sin x. So that's simple. I have mentioned it in numerous times on this series of lectures, and you may already know by now. So what's the flipping over of this graph? What is meant by flipping over? Flipping over some object is just placing it on a mirror effect. If you have some object like this, what's meant by flipping over is you place a mirror here and you take the opposite. So this will be the same here, and this will be like this. So that's the mirror effect. So this is the original, I'm calling it O, and this is the image, this is the mirror. Right? This is a mirror, and this process is called flipping over. So flipping over is you just place it on the other side. So in this video, I will not be talking about the flipping over of the object, flipping over of this curve that is placed over the other, but completely upside down, so upright actually. Flipping over, I call flipping 180 degrees or upside down. This is now what we call. So flipping upside down, when you flip it upside down, you can draw the graph like this. This is x, this is y, this is 0, this is 5 by 2, this is 5, this is 3 5 by 2, and this is 2. Alright? So when you flip this graph 180 degrees or upside down, this curve will be here, this curve will be here, and this curve will be here. Completely upside. This is upside, so this will go down, and this is down, and this will go down. Right? So the graph will be like this. This plus 1 will be -1. This is down, so it will be like this. 90 will be -1. And then 35 by 2 or 270 will be +1. So the graph will be like this. So that is just flipping over. So what happens is that if at 0, this y equals sin x, and this graph I will call y equals some fx, y equals fx are the same and 0. At 5 by 2, y equals sin x achieves an amplitude of 1, that is positive 1, and this graph y equals fx achieves the same amplitude with the same phase and the same angle of -1. So actually what happens is that the same graph is multiplied by -1. So you can search it if you are not sure in the 3 5 by 2 also it will be the same. At 3 5 by 2 in the y equals sin x graph, the corresponding value on the y-axis of the sin x equals -1, and in this graph y equals fx, when it is flipped 180 degrees, so it's made upside down, and 3 5 by 2, when x is equal to 3 5 by 2, y which is equal to fx will be +1. So what actually done is that any value on the sin x graph is made negative in this graph. So actually what happens is that if y equals fx, actually fx is equal to minus sin x. So that's a very important description and important idea, so that if y equals sin x is drawn something like this, y equals minus sin x is just flipping it over 180 degrees. So it's very easy for you now. This curve goes here, and this curve goes here. So you just take it by this, convert it 180 degrees. You take this curve and convert it, you rotate it 100 degrees here. So the same graph rotated by 100 degrees, you take the minus value. So to understand the transformations, you need to understand what is just flipping over 180 degrees or turning upside down. So when you turn some graph upside down, you actually do is, what you do, if it is the same amplitude and the same period, what you do is multiplying the whole graph by -1. Alright, so that's an important idea. So the next idea, then I will come, so this is the beginning of transformations. So as I mentioned before in numerous times, transformations in trigonometric graphs can be divided into two. So transformations, or translations sometimes. Transformations, I'll take it as transformation because translations is another idea. For some graphs, transformations and translations are the same, but for some graphs, transformation means one thing and translation means another thing. So I take only transformations. So transformations are of two types. Those are amplitude transformations, and phase transformations. So as I mentioned before, amplitude transformations and phase transformations are not official terms, are not general terms that are described in trigonometry. Those are terms that are used by me to explain this video. So if you are interested more about this, don't search it on the web or on some book or something like that. So any source of education about these topics, because those will probably be not there. So amplitude transformations and phase transformations are words that are used by me to explain this video. Okay, so what is meant by amplitude? You know that the amplitude of this graph, y equals sin x is 1. So amplitude, as I mentioned before, is the mean displacement from the base axis. or the mean axis. So that is the maximum displacement from the x-axis, and it is at 3 pi by 2, it's equal to -1. So the amplitude is qualitatively different, but quantitatively it will be the same. So amplitude simply is a the mean maximum displacement of a particle of something that is traveling in this graph or wave-like thing from the mean position. So if the amplitude is transformed, either you can increase the amplitude or you can decrease the amplitude. If the amplitude transformed is equal to 1, it will be the same graph. If the amplitude transformed is increased, it will increase the amplitude. And if the phase is constant, if the or the period is constant, what actually happens is that you take this graph and you drag it like this. You drag it like this. So if I take amplitude transformations, alright? Excuse me. Okay. So amplitude transformations, and draw y equals line x again. This is +1, and this is -1. So this is y equals sin x. Alright? So if you increase the amplitude, if you double the amplitude, y equals 2, what is y1 is sin x, and y2 is 2 times sin x. y2 by y1 is equal to 2. So that's simple. y2 by y1 is equal to 2 means you actually take twice value of this amplitude. If this is +1 and this is 2 here, is actually not according to the scale. So don't think about the scale actually. And if this is -1, this should be -2. Doubling the amplitude. So if the period, since the period is the same, then the difference between this actually the half of a wavelength between 0 and 5 in the y equals sin x graph, so the period is the same, so the graph will not change. The only thing is that it will increase. It will drag all these points 2 times that it was on the original axis, original graph. Excuse me. So what happens if the graph is transformed? It goes through here and -2 here. So that's simple. So this is y equals sin x. So this is y equals 2 times sin x. So the amplitude here is 2 and amplitude here is 1. So the amplitude is double. Amplitude is double, and if the amplitude is double, keeping the period or the frequency or the wavelength of the this graph or the wave is on the same axis or the same scale of the same value, what you do is doubling the amplitude, keeping the particles. So any particle on this wave will travel twice that distance in the same time and achieve twice the amplitude at the maximum position and at the minimum position. So that's twice. If y equals 2 times sin x, so if y equals 3 times sin x, it will increase the amplitude by 3 units. So if this is +1, it will increase up to 3. If y is equal to 5 times sin x, y equal to 10 times sin x, if y is equal to 5 times sin x, the amplitude will be 5 here and -5 here. If y equals 10 times sin x, the amplitude will be 10 here and -10 here at 3 pi by 2. So that's very simple, and that's increasing the amplitude by an integer. If y equals half sin x, what will happen? y equals half sin x and draw the same graph, so that it will be very easy for you. So you don't confuse with the graphs and draw the same color. So y equals half sin x is, if you take y1 as sin x and right, and y2 as 0.5 sin x or half sin x, y2 by y1 is equal to half. So that's half, and the amplitude here is half, or 0.5. So what happens is you shrink. You shrink means you are not compressing, you are taking all these points half times your given. So if y is equal to 2 times sin x, you double the amplitude. If y equals half sin x, you are halving the amplitude. So this is the original, and y equals sin x, the amplitude is 1. So in y equals half sin x, the amplitude should be half. So like this, and here minus half. So you take some points like this, you draw the graph, the period is the same, or the frequency is the same, so the graph will be half. So if you double the amplitude of a graph, you will increase the amplitude by 2 units, increase every amplitude, the distance between the mean position and the position of a particle on the on the 2-dimensional Cartesian axis. You will multiply it by 2 if y is 2 times sin x compared to y equals sin x, and if y is half times sin x compared to y equals sin x, we are actually doing is halving the amplitude. So not only the amplitude, the displacement of all the amplitudes, so all the particles on this plane, all the particles. So this is the amplitude here. This is y equals half sin x, this is y equals sin x, or y equals 2 sin x. And y equals half sin x, not only the amplitude, all the other points are half. So y is equal in y equal 2 times sin x, all the points, not only the amplitude, are double from the mean position as it was before. So that's about the positive transformations. Now I am going to talk about what happens when y is equal to some minus value. So I have already drawn that graph, y equals minus sin x. Here I'll take it, or flipping over 180 degrees, or turning upside down. So if y equals sin x like this, y equals minus sin x like this. So what happens if y equals minus 2 times sin x? So it will be the same. You increase the amplitude by 2 of this graph. So y equals minus 2 times sin x. You can draw it completely in a single step, or if you are not sure, or if you are nervous about that, you can draw it within 2 steps. You can flip it over 180 degrees, and then you can twice the amplitude and draw. So anyway, so the graph will be like this. If y equals sin x, so this is x, and this is y. Y equals sin x will be like this. This is 0, this is pi by 2, this is 5, this is 3 pi by 2, and this is 2 pi. Alright, so at 5 by 2 it will be 1, and 3 pi by 2 it will be minus 1. Alright, so this y equals sin x. So I'll take similar. If you are nervous about that, y1 equals sin x, and y2 is equal to minus sin x, and y3 is equal to minus 2 times sin x. And if I need, I'll take y4 as well. y4 equals minus 1/3 sin x. Alright? So I'll draw this graph separately on the same axis, but separately. Alright, so y equals sin x like this, y equals minus sin x is turning this upside down. So at 5 by 2 it will be minus 1, and 3 pi by 2 it will be plus 1. So this is the y equals minus sin x here. Right? So this is y equals minus sin x. And minus 2 times sin x, as I mentioned in y equals 2 times sin x, is actually what is meant by is doubling the amplitude, or making it double. Not only the amplitude, the mean displacement of all the particles in this wave are doubled. So this is y equals minus sin x, so y equals minus 2 times sin x. Amplitude will be here minus 2 and here plus 2. And again, this is not on the scale. Alright? So y equals 2 times sin x will be like this. It will be the same period, so the graph will actually change. Alright, so that's the y equals 2 times sin x. So this is y equals 2 times sin x, sorry, minus 2 times sin x. And if y4 equals minus 1/3 times sin x, y4 divided by y1 is equal to minus 1/3, so the amplitude is 1/3, because the absolute value of minus 1/3 is plus 1/3, but only the amplitude is 1/3, so that's third of the amplitude, that is viewed in y equals sin x. So since it is minus, it will be also flipped over 180 degrees. So turn it up 180, turn it up upside down. Actually, not turn it up, upside down. So this is y equals minus sin x. The best thing is you just compare like this: y equals minus sin x, y2 equals minus sin x, y4 equals minus 1/3 sin x. So y4 by y2 is equal to 1/3. So what happens is, this is just like y equals sin x and y equals half sin x. Compare those. So this is y equals minus sin x. So what happens is you just 1/3 the amplitude. So the amplitude here will be minus 1/3 and the amplitude here will be plus 1/3. So the graph, because the phase difference over the period is the same, the graph will be like this. At 0 it will be 0. At minus at 5 by 2 it will be not minus 1, it will be minus 1/3. At 5 it will be 0 again. At 3 5 by 2 it will not be plus 1, it will be plus 1/3, and at 2 5 it will be 0 again. So the graph will be simply like this. Like this here, and goes to this point and like this. So this is y equals minus 1/3 sin x. So those are the transformations, the amplitude transformations, keeping the period constant. And I discussed in this, why if the amplitude is greater than 0, I'm not talking about the absolute value, the coefficient is greater than 0. The first part I discussed about when the coefficient is an integer that is greater than 0. Then I talked about the second part, if the coefficient is greater than 0 but it is some fraction. If it is not equal to half, say y equals 5 by 8 times sin x, the amplitude will be 5 by 5/8 of that. So that is some fraction, regardless whether it is greater than 1 or less than 1. Fraction in the amplitude when fraction is greater than 0. And then I talked about flipping over, and if the amplitude is minus 1, what happens? It's turning upside down, and then doubling the amplitude or tripling or something like that. You increase the amplitude by a minus integer, and then finally I talked about taking the amplitude of a minus fraction, regardless whether it's greater than minus 1 or less than minus 1. So that's about the amplitude transformation. So overall what I discussed in this video is the positive amplitude transformations, whether it's an integer or a fraction, and negative transformations, whether it's a negative integer or whether it's a negative fraction. And if y equals the amplitude, the transformation is 1, it will be 0, and if it is 0, there will not be a graph. So that's actually, what I mentioned is just an interpretation of y in somewhat of a number line, right? You take it from minus infinity to 0, and then from 0 to plus infinity, you can draw infinitesimal graphs taking y equals sin x like this. So that's simple. So that's about amplitude transformation. So in the next video, I'll be talking about the phase transformations, and in that phase transformations I will discuss keeping the amplitude constant and differentiating or changing the phase so that the period of the graph will be of the same value but the phase changes. So in that video, in this next video and the following videos, I will discuss about changing the period of the graph and changing the overall graph, both the amplitude and the phase in a single graph. So those will be in the next video. So I invite you to visit those videos, and if you are unclear about something or something like that, I am sure that you have not watched the previous videos, and I invite to watch those videos as well. So thank you for joining me and watching this video. So I'll see you soon, and see you on the next video. Thank you.